All right, so this video is about completing a square and then moving it up one notch to completing the cube. And I'll be doing it geometrically so that you can see what's going on. At some point, I'll probably have to do a lengthy lecture on cubics, and the reason is my understanding has evolved over time. I don't think I saw how to put cubics in graphing form until the late 90s. And I don't think I understood the geometric underpinnings of it until about 5 or 6 years ago. Now, I've been at this a long time, and I teach holistically, and that's going to be part of this video. It's just a few comments about traditional sequential instruction versus holistic instruction. I have very strong feelings about the matter. I'm doing these videos because I've got a lot of insights that came over a long period of time, and I want to share them. I don't want them just to go bye-bye with me. So have at it. The actual changing a rectangle into a square is what this is all about. And I remember, so we're looking at ax squared plus bx plus c calculation here. And I remember seeing students factor out an x and rewrite it as x times ax plus b plus c. And of course, textbook wouldn't touch it that way. And so, soccer coach and got pushed into teaching math accidentally, and paid attention to what I was looking at, but always wondered what it was. And I thought slope when I started might have been skiing down Mount Snow. Poor kids that had me, but I stayed with it and kept looking at it and made changes over time. And it turns out that that's a very important way to write this. It's one perspective on understanding minus b over 2a. So let's have at it, and then we'll see how that morphs into minus b over 3a and follows the same patterns of geometric interpretation. So what do we learn from writing it in this way? X times ax plus b plus c. Well, if we isolate x times ax plus b, we can see what makes zeros. We can immediately see 0 gets you 0, and minus b over a gets you 0, and that's a principle of conversion. Get rid of what you don't want, bring in what you do. And so I put minus b over a to the right. Doesn't matter. We don't know, the b terms, positive or negative, so it's generic location. And where's the vertex? Well, the vertex is in between, halfway. Halfway, half of minus b over a is minus b over 2a. Interesting. So I just gave an example of a rectangle. X minus 12 really should be a shorter distance. But I wanted to work with some positive numbers for you. And so we'll just have a little poetic license here on the drawing. But this rectangle, this calculation, x squared minus 12x, can be written as x minus 6 times x minus 6, which is x squared minus 12x plus 36. Very similar. Right? The first two terms are the same. What's different is a constant. So if we get rid of that constant, it brings us back to the original, which allows us to rewrite it this way. And that's really very helpful to have it in the ax minus h squared plus k format, because you can solve that for any equation. Roots are the easiest to see. Minus k over a square root plus minus h. I don't use the quadratic formula much anymore. Why? My understanding of this material has evolved. And more times than not, it's easier to do things differently. Okay. Now, what else do I want to say about this? Not much. So let's go to completing the cube. Well, completing the cube means we draw a cube. And so I use this one, x times x minus 12. Why? Because, again, it's all taking place right here. And if you've done any of the lesson sets, and, I at some point really have to talk about how to use my channel, because I got about 550 videos on there, something like that. And it's all disorganized. Why? Understanding of different processes has accrued, just like area accumulation. And therefore, I made a new video for a new class because my understanding went up a notch. All right? So somehow I've got to try to figure out how to organize that thing so that someone can start with the 311. I just wrote the other day, algebra to calculus in 3 months. I've seen students do it, mostly because of the templative graphing form that I'm going to show on the other side of the board. Okay, but that's why I think I have to make a 2-hour video on how do you teach this in that manner. Where does it start? What's it like? So on and so forth. So if any teachers are looking at this and they want to make a change, then I suggest you do, based on my experience teaching it one way and then teaching it in an entirely different way. There was no comparison in scores and standardized scores and understanding in activity in the classroom. Everything changed. But like anything else, change is scary. No one likes to change. It's work. But the work is, I think, useful, and that video is coming at some point. All right. So I rewrote the first two terms as x squared plus ax plus b. We have been graphing those. So here's your x squared, double root. There's your minus b over a. And a cubic has 3 sides. And it turns out that the point of inflection is right about there for this problem. And it just so happens that's 1/3 the distance to whatever this number is. That's 1/3 the way there. So I decided to use this cube. It's done in other videos. And it works out to be, I didn't do it all, but x cubed minus 12x squared. So this, I made this positive 12. Right? That's what makes it 0. It turns out that this is 4. 1/3 of the way there. And that happens to be minus b, 12 divided by 3. 1/3 of the way there. Okay? And so what we do is we even off the sides. And if I even off the sides, then it's x minus 4 times x minus 4 times x minus 4. And that moves us into putting cubics in graphing form, which is very helpful. And I have a friend who, after he saw it in graphing form, he said, well, I know how to find the roots now. I got to get back in touch with him and have him write it out for me. He used some trigonometry, he did the pi I think. I don't know. You know, no, I'm a soccer coach. Okay, this guy is accomplished. And boy, he rattled that off very quickly just by seeing the graphing form, which doesn't appear to be in the textbooks. And it should be, because this process, minus b over a, minus b over 2a, minus b over 3a, just continues. You can't draw them, but I remember putting a 7th degree polynomial in graphing form. Too many things to consider there that I don't think it was useful at all. But I don't know. I don't know. Maybe it is. But that work is lost. It was pre-YouTube days, and I never recorded it. And it's now no longer something I can find on a computer. But let's continue chatting over here for a minute. Let's talk about, just briefly, the conversation I really want to have at some point, which is about holistic teaching. So I think in '93 is when I made the big change. I got away from sequential to holistic work. And by holistic work, I meant I had a bunch of students who couldn't write the equation of the line correctly coming out of Algebra 2 on a final exam. And I thought I did a decent job. In fact, my scores were 1 point higher than my colleagues. There were some lower final exam scores, but there were 4 of us, and I think I had an 81 mean or median, and I think the next one was 80, and then they dropped off into the 70s. And so I was, typical. But the only thing I was doing differently, I was putting students at the board. I thank John Saxon for that. Went to a talk that he gave one time, and he talked about students working at the board. So they were there, and I think that helped a lot. But I was very disappointed that I was sending kids to pre-cal who couldn't write the equation of a line correctly. So I decided in '93 that the next year coming back, I would do it every single day. Just one problem, every day. I got news for you. Since then, I haven't had anybody get it wrong. An occasional 5 to 7 is 3 units, not 2. Okay, occasional mistake, but over the course of the semester, the process, an understanding of the process, and really can't think of any situation where I'm like, oh, they didn't learn that. Now what happened is that started changing my brain. You do it every day, all of a sudden you keep having conversations, and lo and behold, I had morphed into the Taylor form of a line. The Taylor form of a line is you start with the first y value, How do you get to the second? Up 12, here's a situation here. And then that's your change in y, so you put it over your change in x and make a 0 out of the first number. That's basically the Taylor form of a line. Very quick and easy. It's left to right orientation, and you don't have to do much work once you learn the process. You just, 5 seconds, you're done. And then I realized that quadratic was simply a squared term here and a squared term there. That was my first insight. I went, wow, that means we can write any quadratic quickly and easily with a little practice. And when I say a little practice, it's usually about, I spend 3 or 4 minutes on this when I introduce it. Then I move on because I know the brain can't process it immediately. Then we come back the next day and do it again. And by then, I already got a student or two who's doing it right. By day 4, and each time we do it, take less time, but we do it. More people get it right. And I said, wow, this is good. In fact, I showed it to a colleague who put it in his calculator. This is when calculators were starting to become prevalent. And he compared the tables, and he said, wow, I've been teaching the wrong thing for 15 years. That was his immediate reaction. And so where did that morph into? Well, that morphed into, well, if we could do it with a quadratic, why can't we do it with a square root? And it turns out that it's simply 12 divided by the square root of 5. And I morphed into the ax squared plus k format. I changed this into linear ax minus h plus k because that becomes templative. Then it becomes ax minus h squared plus k, which then morphed into the cubic x minus h cubed plus k. And then I found out that, oh, there's a lot more to getting all the cubics graphed, right? But it evolved. Just by continuing to work on things. So I said, you know what? We got to put students in this templative experience. I don't know if that's the right word I should use, but the repetition. And everybody can learn at their own rate because I make a worksheet. It's about 40, 50 problems long at the start. It's 120 problems at the end of the term. And I got kids whipping those things off in under an hour. And the kids who do it really well, I don't let them use a pencil or paper. I just write your answers. It's good. It's good practice. It's pressure. If you want to improve in soccer, you got to put yourself under some pressure. And I put kids under pressure. And they have fun. And I can give them I already tell them before they even take the final, you already proved to me you're an A+ student. You can do 120 problems and only make 2 or 3 mistakes and you're doing it without a pencil. You're in good shape. So morphed into that being a workshop. And I'm a facilitator, and I never talk more than 7 minutes at the beginning of a class because if I do, I lose the class. They start looking around. So up to the board. Here's the work. Do it in groups. Do it with a buddy. Do it on your own. But make sure you're getting the answers right and have conversations. And so that becomes a workshop. And I never had to give homework. A lot of my colleagues gave so much that I felt sorry for the youngsters. And didn't need it. If you do an hour and a half of math at the board in a given day, that's enough math. Go do something else. Read a short story. Do something else. But progress. I saw the progress and the standardized scores were going up. And so I stayed with it. And it turns out that you can do it at the Algebra 1 level. So I have students coming out of Algebra 1 who, I just did a trig equation here. Students can do that. 10 seconds or left, write the equation. And I usually use the sine function. But if you look at it, the x minus 4, make it a 0. Great, sine is 0. For those of you who have done some trig, 0. But I want to be at a minimum. So I throw 3 pi over 2 in there. And that takes me to -1. And then I can multiply -1 by, midpoint. 23 and 11, I think, is 17. Could have made a careless error here. Put this up quickly. And I have students at the Algebra 1 level doing this work. Not many. Mechanically getting it right, many. Understanding it on a deep level, emerging. But if you're going to repeat it in Algebra 2 and repeat it in pre-cal, I think it makes a big difference getting the mechanics down here. I'm going to do a calculus worksheet soon based on taking a ball, 0-3, kicking it up in the air, maximum 267 after 2 seconds, 67 feet. And the calculus that we've been doing in the calculus worksheets people can understand some of that have been working with it. The problem is getting going. What's the equation? Well, 0.3 reaches 267. That's a 5-second question. And it's another 5 seconds to figure out the time it hits the ground. This is doable. I've seen it, and I've seen ninth graders do it. So I have real strong feelings here. All right. And I'm not going to, if you want to learn how to do that, it's in the Trig playlist. Okay. Disorganized. Okay. But this took me a long time to see this linear relationship. Linear relationship. And I don't think I'm alone. I'm just your typical average student coming out of high school. But one thing I do have going for me is I want to know why things work. And when I switched to this process, I started learning why things worked. And so I would encourage you to go through those early algebra worksheets. I think I wrote algebra to calc in whatever 3 months, something like that, just to be a grab. And I've seen it happen, by the way. And I'm sure there are topics that need more exploration, but as a foundational diving board, hop on. All right. So if you're going to do well in calc, you got to have a good, strong foundation. And I think there's an awful lot of opportunity to do that in those 50 lesson sets, 311 lesson set 1, lesson set 2. Start there. And don't expect to understand even lesson set 1 when you start. All right. But starting a conversation, repeating it the next day, letting the brain have a chance to settle in. Next day, you're starting from a little bit further along. Next day, a little further along than that. Pretty soon you got some mechanical expertise and you keep having conversations about concepts. And that's how I think we can build foundation, and that's how I think we can make some major changes. I know I've started working with my grandson only one time so far. And he's in 4th grade, and I think he needs this process. So we started talking. I had him walk from one wall to another wall. And I said, what's halfway? Okay, and now we're already going to be talking about a number line, and what do you have on a number line? You have some 3 to 4. Well, he can think about these as the walls. And I'll say, okay, go 1/3 of the way there, go 2/5 of the way there, so on and so forth. And how do we add 1/3 and 2/5? We had that discussion on our first chat. And then we talked about 2.5, 5/10, a half. And I don't expect him to have all these things down yet, but we looked at perimeter, we looked at area, we looked at squaring, we looked at cubing. A lot of other things that I can't off the top of my head, but I gave him about 10 to 20 things to think about. And then the next time we work, we're going to just go over that, and I'll see how far he's come and then add something to that. And that's what the classroom experience is like for my students. I watch and I say, how quickly are they picking this up? What's the next thing they got to see? Then I introduce it, which is why the YouTube channel is so disorganized, because never know where it's going to go and never know what we're going to build off of. And I'm never going to know, oh, I see that now. Then I got to add that to a discussion. So there's probably 8 completing the cube videos. And if there's a timestamp on them, you can see the evolution of the process. I'm really on a rant here. But I also feel very strongly about the fact that I think we need to change how we teach. I had a colleague now who's a former student who has revolutionized this process as far as I'm concerned. He's picked out some goalposts. So when I said 120 questions, with 2 months to go in the term, he said, okay, you want an A+ in this class? You got to get up 110, above 110. And it's not just the one test they take. We replicate, because I'm done with all the material at some point, maybe 2 months before the end of the term. I'm not going to add any more material. Might add something to somebody who's flying, and I'll continue working with them. Well, let's do this as a derivative this time. Let's find this minimum value using calc. And I had some 9th grade students dive into that and understood it. So how you treat one student and how you treat the other is very different, but where is it the same? You learn at your own pace. And as long as you're making progress, as long as you get more right on each test, I'm asking the same material. Why do I know it? Because I keep working with the same material. So we got to get our students in the same mold, working with the same material. And I want to thank Emmett for the goalpost idea. You know, you get 70 problems out of 120. It's kind of like the College Board test. You know, you get a 5 if you get above 67 points right out of 110 or 120. I forget. It's been so long since I taught that level. But they give college credit for that understanding, which means you can ask tough questions, you can ask basic questions, you can ask everything from can you spell your name correctly to what's the chain rule say about this. All right? And as long as students are moving forward, then we're educating. So, strong feelings here. On a rant. I'll shut up and move on with the day. Did I say everything I wanted to here? Yeah, I think so. Okay. Yeah, so the graphing template, the zeros and ones graphing template, that's so important that I think I got to redo that because I put a logarithm on as the first graph that you can write in 5 seconds or less. 2 points in an asymptote. Takes 5 seconds to write the equation. Don't have to use a calculator. That process. But for folks who are just starting out in algebra, it's not the appropriate algorithm, appropriate function to put in front of folks. So I think I'll do the zeros and ones video again, principles of conversion, start with the linear, go to quadratic, go to the square root, go to the exponential, go to e to the x, go to ln of x, go to sinusoids, and spell it out. And all I'm working with are the numbers 0 and 1. Okay, now I'm done with my rant. How do I shut this off? There we go.